In this video, I'm going to discuss motion of charged particle in uniform electric field. What type of motion any charged particle can experience if it is in a uniform electric field. Let's take example. Say this is a uniform electric field pointing towards from left to right. Any positive charge kept at rest, any positive charge kept at rest, what will happen? It will experience a force. Let us say this is charge Q. It will experience a force in the direction of electric field. So it will experience a force in the direction of electric field. Let us say if m be the mass of this charge, then it will accelerate. It will accelerate with an acceleration of QE upon m. On the other hand, if you have a negative minus Q charge having mass m placed in uniform electric field, it will experience force opposite to the direction of electric field. See, the force will be opposite to the direction of electric field. You don't have to write here it's a force to be equals to minus QE. You write force in opposite direction. Okay, so this negative charge minus Q charge, this will again experience the same force QE, and but it will accelerate in the opposite direction of the electric field. That means this negative charge will continue to move in the negative x-axis, and its velocity will keep on increasing. On the other hand, the positive charge, it will continue to move in the positive x-axis, that is in the direction of electric field, and velocity will keep on increasing. Now take another situation. If charged particle is projected perpendicular to the direction of electric field. Charged particle is projected perpendicular to the direction of electric field. Let us say in L region, in this L region, electric field is in upward direction. Okay, electric field is in the upward direction, that is from bottom to top. From bottom to top, a positive charge Q having mass m is projected with the initial velocity v0. Now I have to discuss its motion. How it will move, what will be the velocity after covering L distance, what will be its path. Okay, so how we'll do it? First, let's define this as a origin and take this as a x-axis. Take this to be as a y-axis. So first define what are the things are given for x-axis and for the y-axis. For x-axis, since you know there is no force along x-axis, which means there is no acceleration along x-axis, whereas this charged particle will experience force in upward direction, which is equals to QE, which is equals to mass into acceleration along y-axis, which is going to be Q upon m. Now, initial velocity along x-axis, it's given as v0. Initial velocity along y-axis, it's none, it's a 0. Let us say I want to find what is the time taken by the charged particle to cover the distance L. Time taken by the charged particle to cover the distance L. That means the net displacement along x-axis is L. What is the net displacement along y direction? Say if these two planes are separated by distance d. Okay, so first we want to find what is the displacement along L displacement along x-axis is L, what is the time taken by the charged particle to cover the distance L? Okay, by using the second equation of the kinematics for the x-axis, because you can see the three things are given, we can find the time by the using second equation of the x-axis, that's a sx equals to uxt plus half of axt square. There is no acceleration along x-axis. There's going to be L to be equals to v naught t, that gives you the t to be equals to L upon v naught. This will be the time taken by the charged particle to cover the distance L. Since there is no acceleration along x-axis, what will be the velocity? We want to find what will be the velocity after covering distance L. If you write the first equation for the x-axis, Vx equals to ux plus axt, no acceleration along x-axis, that is, it comes out to v naught. That means the velocity along x-axis will remains the same. And obviously, because there is no acceleration along x-axis, so its velocity along x-axis is going to be the same. Yes, but on the other hand, because there is acceleration along y-axis, its velocity along y-axis will come. Okay, and how it will come? Again, use the second equation, first equation for the y-axis. Since initial velocity was 0, Ay is q upon m, and as we know, the time taken to cover the distance L comes out to be L upon v naught. So this is L upon v naught. So we get the velocity along y-axis comes out to be, it's a QEL upon mv naught. So after covering this L distance, we can write the velocity to be equals to, it's a Vx I cap plus Vy j cap, which is nothing but V naught I cap, because x direction velocity will remain the same, and velocity along y-axis comes out to be, it's a QEL upon m V naught j cap. This is the velocity. If we want to write this speed, you can get its magnitude, which is a square root of under root of v naught square plus q e l upon m v naught whole square. So by this way, we can find its velocity after covering distance L. Now suppose we want to find what will be its path, in this region. We want to find the trajectory. Okay, again, let's draw the diagram. We want to find its path or trajectory. Okay, say this is uniform electric field, or better, if I take the previous diagram, say up to this L region, let us say for easy, I'm taking the electric field to be in upward direction. This is L region, okay, and here is the charge Q having mass m, which was projected with the velocity v naught. Of course, its acceleration is in upward direction, that's a q upon m. I'm taking this as a x-axis, this as a y-axis. We want to write its path. Let us say after t, its position is xy. Say it reaches some point P, which coordinate is xy. How will find x? Using the second equation of the kinematics, Sx equals to uxt plus half of axt square. Since ax is 0, so this is x to be equals to v naught t. We get the first equation. On the other hand, writing down the equation for the y-axis, sy to be equals to uyt plus half of ayt square. This is y. Initial velocity in the y direction, it's 0. It's a half of qe upon m into t square. So y comes out to be, it's a qe into t square upon 2m. Now, in order to get the equation of the trajectory, can put the value of t here in this equation. From first equation, we can get the value of t that comes out to be x upon v naught. Substitute here, then y comes out to be, it's a qe upon 2m into t square, which is x square upon v naught square, which comes out to be qe upon 2 and v naught square, can say some constant times x square. That is what, it's an equation of parabola. So that means if a charged particle projected in a uniform electric field, it moves in a parabolic path. It moves in a parabolic path. And that parabola equation comes out to be, it's y to be equals to qe upon 2y m v naught square into x square.